Hello humans, welcome back to Code with Connor. This is the Let's Learn Python course. We are in Unit 5, topic number 4, and I just gotta say, I'm really proud of you because you're here, and that's incredible. And this right here, this is our last lesson. Now, I mean, you're not done. You're still gonna have a project and an end of course project and other stuff like that to do, but this is it. This is all I'm gonna teach you about Python. And then there's a lot more to learn about Python, let's be clear. This is an introduction to the language and to programming, but hopefully you built a good foundation going through the program. So I'm glad you're here. I think that's awesome. To start, we have to go back and look at probably the hardest challenge that we've done so far, which was the maze. Let's do that right now. Okay, so in the last one, we created a maze and we were able to use WASD, pressing enter with each input, not dynamic, in order to kind of navigate our maze. So let's look at the code and see how we pulled it off. So I have a couple variables of R1 and C1. That represents my current player position. I am in row 1, column 1. Remember, they started 0. Row 0, row 1, column 0, column 1. Okay, so I'm in 1, 1. This is my maze. It's a two-dimensional list. So it's a list of lists. You'll notice opening bracket, closing bracket, both square. That represents the greater list, and then what's inside of it. Each of these rows is also a list of strings, comma separated values. I've used X for the walls. I've used an @ symbol for the player, spaces to represent where I'll actually move through the maze. And then we ended off here. I've got an asterisk here for the goal, where you're headed to reach. So I broke my thing into functions. I have a make move function. That's our big one. I'm going to come back to that in a minute. First, we'll look at game 1. So I needed a way to quickly make sure that I won the game. So it's really simple. I just global my maze. Now, I'm not going to modify maze here, so technically I don't need to do this. I can still view it, but you know what? I'm in the habit of, I reference my globals. And then if maze box RC, so current player position, is equal to star, then return true. So I'm going to use that function somewhere in my make move to confirm whether or not the game is over. Okay? So then I did a print maze. So let's look at this real quick. Global maze. So I have my nested for loops. So for I in range, length of maze. So that is the length of the outer list. So that's going to be how many rows there are. So this is iterating through rows. This is saying for I in range, length of maze box 0. So that's saying take the list that's in the first spot and count its size. That's going to be your number of columns. So this is going to loop number of rows. This is going to loop number of columns. Then it's going to print an individual element followed by a space and not go to a new line. It's going to do that for the entire row, so each element in that row. And then when it's done, it's going to jump to a new line and then jump to a new row and then print everything in the next row and so on. So this is my way of printing it in a kind of a clean way. All right, at the bottom, I just call the make move function. That's where everything happens. So let's look at that. So I pull in my globals, RC and maze, and I chunk everything into a while true loop. I'm going to call print maze. So bam, here's your maze. Look at it. Okay. Then collect their choice, WASD. We'll look at my if structure. If it's W, else if it's A, else if it's S, and then else if it's D, and then else is just print invalid entry, continue. So what's in each of these will be pretty much the same code with little tweaks. So if they enter W, W should represent moving up in my maze. So moving up actually means my row value is going down by 1 if I'm making that move. So I check if maze, position R minus 1 and C. So my row value is going down 1, but my column value is remaining unchanged. If that's not an X, so in other words, the position above me is empty. If it's not an X, you could have also done equal equals a space. Okay. If it's not an X, then we're going to move up into that position. So we're now going to say maze in my current position is now a space. I'm going to change my R value of my player. Okay. And then at the end here, I'm going to write the new position to be the @ symbol. But in between those, decrementing R and doing this, I'm just going to double check that I'm not at the end of the maze. So I check, I've adjusted my player position, but I haven't drawn the @ yet. And the reason I'm checking first is because if I draw the at over top of the asterisk, then I'll never be able to see that the asterisk was there. So I'm going to do if game1. That checks if I'm currently standing on an asterisk space. Then print you win and break the loop. If I made it past that if statement, then I know I'm not on a winning block, so I change the value to the at. Else, so if this was an X, then I'm going to print invalid move and continue. So they tried to run into a wall. And then we're just going to repeat this code 4 times. The only thing that's going to change is how we iterate either the row or column value based on direction. So when I go here to A should be a move to the left. So column value going down by 1. Column value going down by 1. Everything else remains the same. When I look at S, trying to go down, my row value is going to go up by 1. Check row value up by 1, increment by 1. Okay. If I'm pressing D, I'm going to the right. So column plus 1, column plus 1. So that's how we built the maze game in the last lesson. That's a big one. And I know I haven't gone through line for line. And I know I don't give you the code. And I know that drives you crazy because you just want me to give you the code. Cool. I mean, if you just want to find someone else's code, go Google it. I want you to type. I want you to write code. I want you to struggle a little bit. That's how you're going to learn. So yeah, be frustrated with me for not giving you the code, but oh well, it is what it is. All right, so that's it for the challenge from the last lesson. Let's jump ahead and let's look at our last lesson, Unit 5, Topic 4. Here we are, the last of the data structures that we're going to talk about, which are dictionaries. Dictionaries are kind of like lists. The only difference is with lists, you have this indexing system built in, the same indexing system we used with strings, where it's index 0 up and it's an integer index value. With dictionaries, we get to control not just the values in the data structure, but we also control the keys. So those are the indices, and they're not just numbers. So let's jump in and see. So I'm going to make a dictionary. So my dictionary equals. We're going to use the squigglers, the squiggly braces. Okay, these are going to define my dictionary. There's other ways to do this too with the dict function. Okay, we're just going to do it the old-fashioned way for now, and you can look at the link in the description if you want to see more. And then what goes in it? Comma-separated values, right? There's a value right here, boom, comma, and then there's the next one, comma, and so on. These are the items that are going in my dictionary. You'll notice my item consists of 2 parts. The part on the left, then a colon, and then the part on the right. This is the key. This is how we're going to find this item in my data structure. This is the value, okay? So key, value pairs are what go inside dictionaries. Now in this case, I've made my keys strings and I've made my values strings, with the exception of this. I made this a list of strings. So a couple of quick notes about setting up dictionaries. 1, your keys do not need to be strings. However, they do need to be immutable, which means they cannot be something that is dynamic. So a string is fine, an integer is fine, a Boolean is fine, but you can't put like a list as a key, right? A tuple is fine. You can't just modify the values dynamically within that variable's data range. So you need to make sure that that's what you're using for a key. Now it's important to note, if you use integers, the order is not there in the same way that it is with lists. The order is not really a thing with dictionaries. And technically it is, but it's not something that's relevant. Okay, it's all about the key value pair. That's what really matters. And we're going to play with this really quickly. So I'm going to comment out some code and then we're going to print this. So we're going to run this just real quick. All we have in there is it prints out our dictionary. So you'll see it prints the key and then the value in pairs, right, all the way through the list. So let's play a little bit with what we can do with this. Let's say maybe we want this key to be an actual integer, for example, and maybe we want this to be a value of 15.5. So this is a float, just to see how we can have those different pieces of variable types in there. We run that, nothing changes, right? Everything's the same. So accessing elements of a dictionary is just like accessing elements of a list. It's just we don't have an index now, we have a key. So instead of printing my dictionary, maybe I want to print box. And this is where we're a little different. We're not entering an integer based on order. We are entering a key. So key 3, which is a string. So I can do that. That should print 15.5. Prints 15.5. Perfect. What if we wanted to print what's in box 2? Now remember, box 2 is not about order. It is about the key value. And there it is. This is the second value. What if we wanted to print, oh, I don't know, this fave colors. So let's do that. Fave colors, because that's my key. And there it is. Now, what if I wanted to just print orange? So that element that's in there, this is a list. Now, lists still have their same indexing procedure. So once I've done this, my dictionary box fave colors, that's returning an entire list to me. And now I have the power of a list, and I can do stuff with it. So for example, I can add another box here and put box 2, 0, 1, 2. Run that. And there's orange. So once I have my list, I can then use regular list notation. But the list is a value stored with a matching key in a dictionary. So this is how we use dictionaries, and they can be used for all kinds of purposes. And the nice thing about a dictionary is you can add stuff to it. So you can add new items to the dictionary. You can overwrite old items. You can remove items. You can pop. You've got a lot of that same functionality that you would have with a list. It's just you're not limited to this index system of numerical ordered indices. You're able to be flexible with the key value and how that compares to the value. So that's a nice piece of the way that they work. One thing that's important to note is you can't have more than one key value that are the same. If you try to do that, what happens is it just overwrites whatever the value was that was paired with that key before. I'll give you an example. So we'll just print box 2 here. And let's do my dictionary. Box 2 equals 7. This is just going to overwrite whatever's associated with that key, right? It's not actually going to make another addition to my dictionary. If you wanted to add something that wasn't already there, you could just do my dictionary box and then put the key value in. So new key and then equals, and then put the actual value that you want it to have, true. And that's now going to be in that dictionary. So if I ran that, say like that, and then run it, right, you can see that that's now in there, new key true. So we can add things like that. There's some functions we can use too to kind of pull stuff or whatever. I'll review just a couple quickly, and then we'll wrap it up. All right, so quickly we'll just go over deleting. So if you want to delete an element from a list, so here's a way we can do that. So let's say key 1. So the del command is reserved in Python. So del from my dictionary key 1, and this will remove the key value pair that exists with this key value. So it's not just going to eliminate the value and leave the key. It's like the whole pair has to come out together. So this will work to delete that value. You can just do del my dictionary key 1, and that works great. If you want to remove something. You also have the ability to do some of the similar stuff you did with lists, like pop, and then you have it, right? And then you can do something with it if you wanted to do that, which removes it and gives it back to you, which can be really useful. There's a clear function that you can use on dictionaries to, wipe the whole dictionary. There's also a get, which will like give you the value if for some reason you wanted to do that using a function versus just going directly to the key. So there's a bunch of stuff there, and I'll put a link in the description with a little bit more detail about dictionaries. But that's kind of the idea of how this data structure works and how it's different than lists, which we've already used. So just remember, the key value is in your control. You can't duplicate it, and it needs to be an immutable data type. Typically, we'll use strings or something similar. And then the value can be of any data type. All right, those are some important pieces to know with dictionaries. We're not going to do a challenge for this last one because we're going to jump in and look at the unit project next, which is a big one. So I don't think there was a need to do a little mini challenge on dictionaries. Thank you for sticking with me for the lessons. This has been really fun to make, and I hope that it's been helpful for the people that are out there trying to learn Python for the first time, and I'd love to extend on it, do something a little more advanced in the future. We're going to see you back real soon to do the project and then the end of course project, which we'll do at the very end in the last video. So like, share, subscribe, do all those fun things. Kind of keeps me motivated. We'll see you back real soon.